So, to thank him, let us start with a prayer song by our CKC choir girls.
The shall be service of blessing. This is the promise of love.
And your staff, they comfort me. This is the word of the Lord.
Thank you, Ms. Sajini. I request Mr. Praveen Kumar from 3rd year CSE to give a welcome address.
Very good afternoon to one and all gathered here. A warm welcome to everyone to this webinar of our college. On behalf of our college, I am S. Praveen Kumar from 3rd year CSE. With the blessings of Reverend Father J.E. Arulraj, I welcome Administrator Reverend Father R. John Brito. We welcome you, Father. The essence of great leadership is influence and not authority. With this note, I would like to welcome the respected principal of our college, Dr. M. Jayakumar. We welcome you, sir. To be inspired is great, but to be an inspiration is an honor. With this note, I would like to welcome the honorable chief guest of today's webinar, Mr. Vijay Daniel. We welcome you, sir. It's our pleasure to welcome the backbone of our department, honorable head of our department, Professor T.B. Dharmaraj. We welcome you, sir. Next, they are like candles who spend their whole life in giving light to many students. Yes, I would like to welcome all the teaching and non-teaching faculties. Last but not least, I would like to welcome all my student friends to this webinar. Stay positive, better days are on your ways. Once again, I welcome everyone to this webinar.
Thank you, Praveen Kumar. I call upon Mrs. Smita from 3rd year CSE to give an introduction about chief guest.
Good afternoon to everyone. Our chief guest, Mr. Vijay Daniel, working in Erection, Ireland as senior system analyst, doing system studies for the new customer requirements. And he also has 17 years of experience in telecom domain, worked as a software developer, scrum master, senior tech lead, lead consultant, project manager, line of people manager, and solution architect. He has worked in many companies like Erection R&D in Ireland for 2 years, Erection R&D in Bangalore for 8 years, British Telecom in Bangalore for 1 year, UK Payments Network in Bangalore for 4 years, Nilagiri Network in Ooty for 2 years. He also developed many products like legacy to modern cloud native application, hands-on experience in using open source applications, and contribute back to the open source community. And we are so honored to have Mr. Vijay Daniel as the chief guest of this webinar. We welcome you, sir.
Now, I request our chief guest, Mr. Vijay Daniel, to carry on with the rest of the session.
Jay. Jay? Wait. I'll ask the principal to. Sir, principal sir, want to.
As well as all the participants from various places. Very good afternoon to all of you. Really, I'm very happy that Department of Computer Science and Engineering of Christ the King Engineering College is organizing
So what the customer can do is they buy this software and they put it in any of these things. So in order to have those decoupling between the platform and the application, we need to build it on top of Docker and Kubernetes. So this is the key here. So when I develop my application in the form of containers and which can be managed by Kubernetes, and those containers are built based on Docker, then these applications can be deployed in any cloud. So that's why it's called cloud agnostic. So, or I can develop an application which is very specific to these cloud providers. I can ask my customers, no, you need to run my application only in Amazon. Because I would have built my application based on the Amazon technology. The service is what Amazon is providing. So these are the two broader aspects here. So that's the basics about the cloud native application. Okay, so basically what you're going to take from this slide is a cloud native application is which that is using cloud-based technologies. Those technologies are like container, service mesh, microservices, and it should be a distributed application. Okay, it should have APIs. It's a programming interface. The communication between both components or multiple components in the software application. All those things should be based on these APIs that we call it as an application programming interface. Okay, so if you use all these things and if you build an application, and if you build an application which is cloud agnostic by using Docker and Kubernetes, that's a cloud native application. Okay, or if you want to build a cloud specific one, you can ignore this Docker Kubernetes, but then you can directly start using these cloud providers their services, and then you can build your application. That's another way of building a cloud native application. Okay, so I'll move on to the next one. Here basically I wanted to talk about the advantage of a cloud native architecture. Okay, so why you want to build a cloud native application? So why can't you just build a legacy one? And what is the main difference, and what are the advantage you are getting here in cloud native application? Okay. The first thing is it's a multi-tenancy. So as I said, the cloud provider will be somewhere like might be in Canada, okay, or might be in Sweden, but he provides you the hardware, he provides you the tenancy. Okay, tenancy means like it's a kind of an account, you can say. Okay, Ericsson buy in tenancy there. Example, if Oracle runs in California cloud, I can buy an account there as an Ericsson. Okay, and from your college you can buy an account there. So for all your labs you can move to the cloud. You don't need to have a lab there. So you can just buy a tenancy with these Oracle in California, buy an account, and you say I need so many CPUs, I need so many memories and so many storage. That's all. What you say here is you don't need to have a lab there. You don't need to maintain. You can use those space for something else. Okay, so all that you need to know is you need to have a laptop or a machine so that you can directly log into those cloud, and you can use their hardware. You can use their CPU, memory, storage. So that's the advantage here. So the cost is very less. So of course I'm taking your lab. I'm sorry for that, because it will be easy for you guys to understand. That's why I'm relating your lab. Okay, so in terms of lab, you need a multiple person to maintain the lab. You need to spend money for the power. If something breaks down, the service will not be available for the students to use the lab. Okay, so there'll be service disruptions. Okay, there are many drawbacks of having a lab. So this is a very small picture I'm giving, but it's the same case for a company like Ericsson. Okay, so when I talk about big companies like Ericsson or Nokia, Siemens and all, in one day their business will go into multiple million losses. So their business should not stop. If they have their own data center, if there's a power disruption or if there is any failure there, they need to put a lot of people to resolve the issue, and they need to maintain it without see in order not to fail for a single day also, you need to put so many effort to maintain it like that same level, right? So it's all too costly, and it's error prone. So basically, in a nutshell, in the cloud, multiple organizations can use the same cloud. That's optimization here. Okay, scale as you need. So it means like say today's Christmas or Diwali, some function is there, so people are going to shop more online. So example, a product like Amazon or Flipkart, so there on that particular day the demand is going to be more. So how they are going to meet the demand? So if they buy so many hardware and keep it in their local data center, and that hardware is going to be used only twice or thrice and for the entire year. So for rest of the year, the hardware will not be used. Like the load to the server will be normal. Okay. So in order to cater these dynamic loads, cloud is the best mechanism there. Okay. So what they provide is they provide you an infrastructure where you can dynamically increase the scalability of your application. You can start using, when the load is more, you can start using many CPUs, and you can scale it down. Okay. It reduces cost here because you pay only for what you are using. If you are using 5 CPUs today, you are going to pay only for those 5 CPU. And if you are using 50 CPU tomorrow because of a load, and you're going to pay only for those 50 CPU. And this is a predictable pricing here, because you know how the application will scale, on what needs, and when it's going to scale. There are many benefits here, so to reduce the cost. And cloud is a secure one. Like your data center, you can also have your own security in place, so that you can have individual namespace. So namespace is like you can make your application run under the namespace, so that if another company comes, if they deploy their own application, so both will not get in confusion. Okay, so we will not overstep on the other application's space. So the security will be provided by this namespace. Okay, and the velocity, basically they are talking about the speed in which you develop a cloud application. Eh, it's entirely based on this DevOps culture. So a team will take the entire responsibility from requirement gathering, building, testing, and then to deploy also. So the team will directly deploy into the cloud. So it's a CI/CD based implementation. I'm not sure whether you guys know CI/CD. It's continuous integration and continuous deployment. So it's not like olden days where we develop and we put it in a software gateway, and the customer will take it from the software gateway and they will install it. So these things have gone now. In modern days, it's seamless. So we have CI/CD pipeline which directly goes to the customer sites and deploys our software there. So the upgrades and installations are very quick and easy. So the key here is the resiliency and high availability. The cloud is very reliable. Okay, it's more reliable than the lab what you guys have. So your lab might be prone to failures, but cloud is not the case because it's maintained by the high professional people. It's billions of dollars invested there. They have the redundancy, so when something fails, immediately it will flip to the other hardware. So that high availability is always there. They promise you like 4 nines or 5 nines. So when I say nines, that's how they talk. Availability 99.99% available. So hitless upgrade is like it's an in-service software upgrade. Like your software will still keep working, and then you can upgrade your software. So I'm not stepping into all these things in detail, but it's every single topic is 1 hour talk to me. Like I can talk so much, but overall from the slide what you guys are taking is there are multiple advantages in cloud native application. The few things which you need to remember is it's multi-tenancy, it scales as you like, and it reduces the cost, it improves your development and deployment speed, and it's highly available, it's resilient. Okay, and it provides you the hitless upgrade. Okay, and forgot about this, the AML and all. It's again a big topic. I don't want to confuse you guys with all these terms here. So that's the takeaway in this line. Okay, so I believe you guys are comfortable with the slides. Are there any questions to me, guys? Stop me as and when you like. Okay, so the next topic which I thought of exposing you is like the type of clouds. Now you know what a cloud is, you know what a cloud native application is, and you also know what are the advantage of a cloud native application. But you need to know what are the types of cloud available so that you can use it, right? So for you to make a call, you need to be aware of what are the types of clouds available. So these are 4 basic types. One is public cloud. Okay, so here public cloud is something which is accessible for anybody. Okay, in the public cloud, any organization can buy an account, a tenancy, I would say. Okay, they can buy a tenancy and then they can start using their tenancy there. Example, a Pepsi or a Coke, a company like spinning mill. Everybody can buy an account and they can start using their hardwares, which is there in the public cloud. Okay, they'll just get a tenancy. That's example. The best example are Amazon Cloud, Google Cloud. Okay, a private cloud. What is a private cloud? It's the exactly opposite of a public cloud. So this is very specific for that organization. Okay, it will not be shared. The hardware will not be shared, and the entire setup is given dedicatedly to the organization. Like Ericsson. Okay, Ericsson is a telecom vendor. It has very sensitive data. The private data of the people. So people think twice, should I put these data in a public cloud? Because there is a security issues, right? So and companies like British Telecom and all, they don't like that their data to be moved across the country. Every country will have their own policy. Okay, so data protection policy. The India will not allow Indian data to go abroad. So in those cases, we need to have those data center within India. Okay, so there are specific needs to have this private clouds. Okay, but still it's a cloud. It has all the features of a cloud, but it's just private and specific for that organization. And this is the community cloud. Community cloud is again it's a collaborative one. Like it has a multi tenancy, but it's a group of distinct organizations that they're going to use this cloud. Okay, this is open for all. The public cloud is for all. Okay, this community cloud is not for all, but a group. But this private cloud is only for a single organization. Okay, and this is a hybrid. hybrid is a combination of all these things, guys. Like you can have public cloud, and also you can club a private cloud. Uh, so basically, you build an application, right? So in the application, you can run part of your application in public cloud, and the rest part of your application in a private cloud. So that's called a hybrid cloud. Okay, so it's everything is based on your application and what you build and what you need. So based on your application, you need to decide, should I go for a public cloud? Should I go for a hybrid, community, or private? So the conclusion here is, think about your application, what your application needs, and pick the cloud accordingly. I'm going to talk about the cloud services. I'm just going to give a 2 minutes pause here, just to know, is there any questions people would like to ask me? Okay, I'm on. The cloud services. Okay, so basically the cloud is providing 3 services for you. One is IaaS, it's like infrastructure as a service. The other one is PaaS, which means platform as a service. SaaS, it's nothing but software as a service. Okay, so the leftmost one is a kind of a legacy one, or a data center maintained by an individual company. Okay, let's say you guys, when you develop a application tomorrow, okay, it's not just a Java program. What you do in lab, that's very basic thing. Okay, forgot about that. Have a bigger picture. Okay, so when you develop an application, you need to do all these things by yourself. Okay, the very first thing is you need to have a network. Okay, internet and connectivity between these machines are very important. Okay, that's the base here. And the storage. Okay, storage is not just your hard disk. Okay, commercially the storage is very big. So we used to deal with TBs of data. Okay, terabytes of data. So the storage is very big. It will be elsewhere. The storage is in a cloud. It will be elsewhere. It will be connected through the actual hardware, the CPU, through an internet. Okay, it will not be on the same boxes. Okay, it will be different. The storage is a different solution altogether. And there'll be servers. Like servers are nothing but the CPU and a little RAM in that. So in data center, servers are not what you see in your lab, but it will be just a single motherboard kind of a thing. Just take the chip, insert it. That will be a server there. It will be a rack mounted, very big rack mounted servers will be there. And the virtualization, virtualization is the key here. So basically, you'll have the hardwares and you create a virtualized. I'm not sure how many of you are familiar with VMs, virtual machines, but virtualization is the core here because we want to counter more load. It's kind of an optimization. Okay, so though you have 10 CPU, you can create 2 VMs, let's say, on top of that particular hardware, saying that each VM has 10 CPU. But you give a picture to the external world saying that there are 20 CPUs available, but actually what you have is only 10 CPU. The reason is you create a virtualization there. It's an optimization. Not all the 10 CPU will be utilized at the same time. So what you do is you do a time slicing there, and it's a very big topic. So I don't want to take more time here spending here. But all you need to understand is virtualization is there to optimize the actual physical hardware. Okay, that's in a single word. And of course, on top of virtualization, you need to have an operating system. Okay, once you have the virtual machines ready, you need to install operating system there, and then you need to have some middlewares in case if your application is depending on that, and you need to have runtimes. Like Java has its own runtime, like that. You need to have whatever your application is depending on. You need to have those runtime, and then your application will depend on those data, right? And you will have your own data and your applications. So this is the entire stack. Okay, so if you're providing a fully commercial solution, you need to have the entire stack ready by yourself. Okay, this is a kind of a tedious job. So when you think about the software as a service here, the advantage what you get here is everything is provided for you by the cloud provider. All you need to do is just pay him the money. Okay, so yeah, here, as I said, it's a cloud, right? You get all the advantage of a cloud. If you want to get some benefits, you need to pay money. Nothing comes free, right? So, but then all the benefits are really good. So whatever you pay, it's really paying you back. Okay, so software as a service, like they provide the entire stack for you. Cloud provider like Oracle, Google, Amazon, they will take care of everything. So all you need to do is build an application, or just buy the application from them. Okay, so you'll say, I need this application, I'll pay for you, you maintain this entire application by yourself. So all you need to do is just pay for the application usage. That's all. It's very simple. They provide the entire stack for you. In platform as a service, you buy a platform from them. Okay, the cloud providers will provide you networking, they will provide the storage, they'll provide you the server, visualization, OS, middleware, runtime, everything they will provide. All you need to do is you need a team in your organization to develop an application and to maintain the data for them. So you'll have an in-house development team who makes this and then who deploys on top of the platform. Okay, so infrastructure as a service. So you go one level higher, you take more control here. Okay, so in your organization, you develop the application and you take care of the data, and also you take care of the middleware, operating system, and the runtime also. So you what you buy is basically you buy an infrastructure. Okay, so I need so many vCPUs. We call vCPUs because it's virtual CPU. It's not the actual CPU. So you buy vCPUs and memory from the cloud providers, and from then you need to build on top of that. The cloud provider will provide you all these storage solutions. He will provide the networking between those servers which you are ordering, and he will take care of virtualization, everything. Okay, so this is another service which the cloud provides you. So now again, once you pick the types of cloud, and then you are in a situation to pick what kind of a service I need to pick, it's entirely in your control. You can decide which one I need. Okay, so how much you want to spend and how much you want to build in house in your organization, what's the control you need to have, and how much you need to provide it to the cloud provider. Uh, it's all your situation basis. Okay, so that you can make your own decision. You have 4 kind of options. You can pick any of these, and 3 of them are on cloud, and the last one here is in your own data center. Okay, is there anything I need to clarify here, guys? Okay, just a minute, I'll ask my daughter to be quiet. Hope you guys don't mind. Yeah, sorry about that. Okay, so this is the cloud infrastructure components. Okay, so this is the entire stack, how the cloud is being built. Okay, the cloud is built on a data center. Okay, so the basic is you will have a very big building which will have all these CPUs in the form of big racks, and all these CPUs will be interconnected through the networking, and you need networking solutions like switches, routers, and gateway. So using the gateway, you can talk with other data centers across the world. Like it's a very big space. And on top of that, as I said, you have the servers and virtualization, so that you can cater many tenants, and you will have storage in those data center, and you need to have networking. You need to link all these things into a network solution. Um, then you need cloud infrastructure management services, because you need something to manage all these things, right? So you need an application to manage here, and on top of that, you need some toolings to manage your own application, because you are deploying your application here, and you need to kind of a tools that could manage your application also. And on top of that, it's the user application and the services. So this is the application which you develop. If you just develop a hello world Java program, that will be at the topmost level. So there are many things underneath the thing. Everything should seamlessly work. Okay. So again, the reason why I decided to talk today on cloud native application. Okay. So this slide is going to inspire you guys a lot. Okay. So especially when I talk in terms of money, I think everybody will be interested. So if you see the money here, which the survey is talking about, it's a very big money, 180 billion cloud market. Okay, so Amazon leads 180 billion cloud market. So this is the very recently what's the need of Sri Lanka, right? It's just 50 billion. So this is bigger than a nation. Okay, the money involved here is so big, and everybody are competing in the space. And in future, everything is cloud native. Whatever the application you are building, everything has to be cloud native, so that the end customer demands that I need an application which is cloud native, so that he can have these options. He can put it in Amazon, he can flip it to Azure tomorrow, and because everything based on cost. Tomorrow, Google will come up with some different tariff which suits the customer, so he will move from Azure to Google. So you need to build an application which is seamlessly you can do this transformations. So that's why the cloud agnostic way of developing an application is very much appreciated. So when you guys see here, there are multiple cloud providers like Azure, AWS, Google, Alibaba, IBM, and there are many actually. I just listed the topmost providers here, but if you see in internet, there are multiple cloud providers. Okay, so what I basically want to say here is this is one of the very critical area where you can think about your career. Okay, so in college when you study, you can when I at least when I study in college, Dharmraj sir has inspired me to learn C programming. That's how I started. He taught me C programming. So the very basic push for me is the addition of two numbers, the swapping, palindrome, the very basic programs. So when I did that, I was very happy to do the programming. And when we provide those solutions, he encouraged us a lot. So that basic motivation made me to do a lot of programming in future. Then I went on like exploring many programming languages, and then that's how we grow, right? So in your college days, along with your basic programming, what I like to inspire is do a cloud native application. Okay, so this is the key here. So when you come out of college and you say in your resume, I am good with cloud native application, I know Helm, I know Kubernetes, I know the terms which I'm going to talk in future in the next slides. If you say I know all of these and you are stepping into such a big billion market, okay, so this is a very good space, a very interesting one. I really want you guys to get inspired here, and then think about this today, and focus here and prepare for yourself. How can I build a cloud native application? How can I get into the space? This is the future, guys. Okay, so I'm going to talk about the distributed computing. Okay, so basically, I think you guys would have had this distributed computing in your syllabus, maybe, or may not be. I'm not sure. But in a nutshell, what a distributed computing is, I'll quickly go through this definition. It's an interesting one. Okay, distributed computing or distributed processing is the technique of linking together multiple computer servers. Okay, it's linking multiple computer servers over an internet. Okay, into a cluster. This entire setup now is called a cluster to share data and to coordinate processing power. So these guys are sharing data and they are coordinating the processing power. Okay, such a cluster is referred to as a distributed system. So this is a system. Okay, this is called a distributed system. So you have the hardware, you have internet connecting between all those things, and they are ready to share the processing power between them. Okay, so everything put together, it's called a distributed system. Okay, and distributed computing offers the advantage in scalability. Okay, so when you want to process more data, when the load is more, all you need to do is add a hardware to this, put the network in between. That's all you need to know. So you can grow dynamically, you can grow, scale out and scale in also. Okay, the performance is good because instead of one single server, now you are banking on multiple servers, and you are attaching more servers also dynamically, so you can do many things in parallel. So the performance is obviously good. Okay, it's resilient because if you bank on one single hardware, like how you program in your lab, if you just bank on one single hardware, and if the hardware crash, then all your software and application data, everything goes up, right? So that's not the case. It's very resilient. It's redundant here because the data will be replicated across. There will be redundancy on the data, and your application also will be replicated across. So the redundancy is very good. It's a very reliable one. Okay, and it's cost effective also, because these hardwares are not a very so in olden days, like what we have is we buy a very costly hardware. It's a vertical scaling hardware. If you need to tell upfront, okay, for my application to run I need 250 CPUs, and those 250 CPUs are kind of fixed. You need to you need to enhance your application only within those footprint. If you want to add, let's say 260, if your application is going to 260, all you need to is scrap out this old hardware, buy a new one which is 300 CPU, and then again deploy your application there. That's how they were building when I joined the software industry. Now that's not the case. Okay, so it's all changed. It's all horizontal scaling now. So you can make a note of all these terms parallelly. If you guys are actively looking to my speech, take a notebook and make all these words, whatever I'm saying, so that offline you can Google and study what horizontal scaling is about. Like, okay, so when you develop an application which can use all these internet and multiple servers and resiliency, okay, it doesn't. Nobody is going to provide you the resiliency. You need to build an application which is resilient. I'll tell you how to build those applications down the line. Okay, so that's distributed computing. Okay, I'm going to do a quick check. It's half an hour now, so I still have half an hour to cover. Yes, I think I can make it. Yeah. Okay, so the next topic which we are going to talk about is microservices. Okay, so now you know distributed computing, right? So I'll relate this microservices to that. Okay, so you have all the hardwares. Now how to use that? Okay, basically a microservice is a small part of your application. Okay, so which independently runs. Okay, it has this independent life cycle. These microservice, an application, if you see when you develop a cloud native application, that cloud native application will have multiple microservices under that. Okay, it's basically a distributed system. The application which I work, the microservices are hundreds in number. So we have so many microservices. The application will, when a user, like the client, when he makes a call, okay, the call actually goes to an API gateway, and the call goes to all these services. The service is also interlinked. Okay, so one service A will call service B. Okay, and that's how, like, it might call service C, D, like that, or the call can directly return from the service A itself back to the user all the way back. Okay, so so in olden days we built a monolithic application. The entire application, like say your final year project, when you build a project which is based on Java application, you write multiple classes, right? So you write hundreds of classes, everything put together in one jar file. Okay, that's a monolithic application. Okay, so what we do is we break all those hundreds of Java classes into 5 class here, 5 class there, and we build a small microservice out of that, and all these microservices will be running in your application. So that's called a distributed system. So that's how breaking the monolith into distributed microservice based application. These are all very big topics, so I can talk more here, but it's going to take time, and I might confuse you guys more. So in order to keep it very simple, in order to make everybody understand, okay, so I'm avoiding all those complexity. All I'm telling you guys is microservices and small piece of application which can run independently. It has its own process. Okay, you can upgrade this microservice on its just this microservice alone independently. Okay, so the life cycle of this service is not depending on the entire application. Okay, so there are many advantages, guys, here. So basically you need an orchestrator here to manage these services. So for you to say my application is up and running, okay, so you need to make sure all these services are up and running. Okay? So how do you do that? You do you need a tool which can manage all these services, which can orchestrate. Okay, so one microservice, you go here, another microservice, you go in this hardware, you run here, and okay, I'll make a connectivity between these two microservices like this, and the third microservice, okay, you go here, you run here, so and okay, something happened here, this machine is going down, so now whatever runs here, you know, although microservice C, you come to this machine here, somebody has to do all these things, right? That is actually done by the orchestrator. Okay, the orchestrator manages the services here. Okay, so I'm going to give a pause here because I've covered a few more slides, let's say 4 slides. My intention is only to bring some basic exposure for you guys. I'm not sure whether you guys are aware of all these things before. Is it too basic or it's too complicated? Any feedback to me, I can talk accordingly. So I'll just give a pause here for anybody from the students to say, um, is it too confusing or too high level or too low level? Am I talking sense here? Okay, come on, guys. No worries. Like you can feel free. No hard feelings. So I don't mind if you guys say no, this is not to me. It's too complicated. I can talk even easily, or this is very basic. We already know this. My teachers have already taught me this, and what you are talking is very basic. What we expected is something more complicated. Then I can talk accordingly also. So it's up to you guys. I'll just give a pause here, get a feedback.
Ask anyone to give this feedback.
Yeah, let me ask Shilpa because I can see Shilpa there. I would like to call out a name. Okay, I think she's not there. Maybe, or she's there. Yeah.
Call out name and say, ask.
That's okay, Shilpa. I'm not hearing you. But anyway, Jerish, there's another person next. It's difficult for me to get a feedback there. Then I believe.
Can I call Vijay? Can I call the students?
Yeah, yeah. Of course, Dharma sir. Sure.
Reshma, can you give your feedback?
Yes, sir. Can you give us some example projects for final year, sir, in cloud computing, and second year, pre-final year also for many projects, sir?
Okay, so that's a good question there. Like, as I said, like instead of developing a one monolithic application, okay, so I'll say, yeah. So that's a very good question, Reshma. So what I'll do is like when I cover all these slides, I'll tell you how can you make a normal Java project into a cloud native application project. Okay, so that when you build a final year project, you can cover all these aspects, and then you can build your application accordingly. Okay, so basically in this slide, what I'm telling Reshma, you need to, instead of writing hundreds of Java classes, all you need to do is you break down the hundreds of Java classes into microservices. Okay, so you need to group those classes. Okay, example, if you're building a hotel management system, it's a rough example. Okay, the hotel management system needs a few set of classes to manage the tariff, a few set of classes to online booking, and few set of classes to take those order and save it in the data store, like that, right? So you group those classes. Okay, you group those Java classes and create a microservice. Okay, I'll talk about how to create a microservice down the line. Okay, so have all those microservices running. Okay, and then try to see how we can build in the resiliency and how we can build the redundancy there, and how you can scale those microservices up and down based on the load. Okay, and so that it is a very good exercise for your project, and you can document all your observations there. Okay, so my first advice is take any example. It could be anything. Like see, the topic doesn't matter. The booking online hotel reservation system is a very old one. It doesn't matter. But what your faculty, they will look is what newly you have done there. Okay, it's an old legacy system only. Old, the idea is not new, but what is new here, the way you build that online booking system, because you build it based on microservices, you are using cloud there. So that's something new. That's a the end goal. Whatever the solution you offer really doesn't matter. How you implement it is actually matters here. Okay, so my suggestion would be take any use case, whatever your previous seniors have done. Okay, that's absolutely fine, nothing wrong in that. Take those projects, okay, convert that into an new technology based. This is a cloud technology based, right? So you are converting that. You are doing many things new there. So absolutely, you can do all those things. Okay. So here, this is the Docker and container. So I'll keep addressing Reshma's question throughout these slides here. What you need to do when you're building a cloud native application. Okay. So the next, let's say, the time is 10:30. So I'll take another 15 more minutes. But the next 15 minutes is going to be really tough. It's going to be a high level knowledge sharing. Because in the interest of time, I don't want to talk more also. But these are the very key here. Okay, so basically, the Docker and container. So when you build your application, you need to build a container. Okay, so to build the container, you need Docker. So Docker helps you to build a container. Okay, so the very basic building blocks here are the Docker. Okay, Docker is an open source container platform. Okay, it enables you to build those packages so that you can build a container. Okay, so now you will ask me, what is a container? Okay, a container is nothing but it's an standardized executable component. Okay, so it has everything into that. A container will have an operating system. It will have all the libraries which your application needs, and it will have your application also into that. So everything put together, we can create a container. Okay, so the next thing you need to know is a Docker engine. Okay, because you need to host your application on various host OSs. Let's say it could be Windows or it could be Linux. Okay, so in order to give that transparency, there's a Docker engine there. So your container will be supported by this Docker engine. So that it will provide some transparency between the underlying operating system. Okay, and there's something called Docker image. So basically, when I build an application, I build an image of that application. Okay, I can take this image and I can run it on the Docker engine. Okay, that basic image what we are building is called a Docker image. So the way we build Docker images using by this Docker is a platform, right? So using those commands in the Docker, we can build Docker images. Okay, and we need to store that Docker images somewhere, right? So that place is called Docker registry. We build an image, we push that Docker image into a registry, and the registry is the place from where you fetch all those Docker images and you run your cloud. Because cloud is somewhere, like cloud is, it might be in Sweden, it might be in Switzerland, or anywhere. Like when you go into cloud, you should be able to pull those images what you build in your laptop. So you need to put it into the registry, and the registry should be visible in the cloud, so that when you log into the cloud, you can pull your images. So image is nothing but your application, right? What you build. So it's all the formats, like how you group things together. Okay, so that's the very basics of the Docker and containers. Okay, it's a two deep concepts here. It's not like one line as what I said here. In the interest of time, I made a very basic introduction here. Okay, but definitely, guys, this is the future. Spend some time here, learn about all these Docker containers, Docker engines, and all, how it works. Okay, so just to give a initial push here, the VM is an kind of old mechanism, like very actively used like 2 to 3 years before. Everybody works on virtual machine, and now everything is container. Okay, I'm talking about the recent technologies, the containers. Okay, so let's talk about what people did 3 to 4 years before. They will have a virtual machine. Okay, they basically this is based on the virtual machine. Okay, so there will be a hardware. You have a physical CPU memory, and you will have a host OS on that hardware, and you install an hypervisor. I'm not sure how many knows the hypervisor. Hypervisor is the one which will provide you the virtualization, the vCPUs we call virtual CPUs. So you take one CPU and I can make it into a two CPU, because what we buy actually is the physical one CPU. With the virtualization concept in place, I can do a time slicing here. I can make that one CPU to two CPUs. That's by using the hypervisor. Okay, and on top of that, once by using the hypervisor, I'll create a virtual machine. Okay, so in that virtual machine, I'll have a guest OS. So in the virtual machine, I can use Ubuntu. Here I can install Windows or whatever I need, and on top of that, you will install your application. So this is the virtual machine stack. So in the containers, in the container world, how it works is you have the same hardware. It's not the vCPU, it's the CPU and memory. Okay, and you have a host OS, and on top of that, you don't need the hypervisor. You don't need to create multiple VMs. Okay, so you can directly run your containers on top of the container engine. Okay, the container engine is an example of a container engine is Docker engine. Okay, so there are many other container engines like Run C, or there are many things. You guys can feel free to explore that, but your application will run on this container engine. Okay, so the way you build this container is by building a Docker file. Okay, so you build a Docker file. This is a sample Docker file. Okay, so I say from Ubuntu, so which means you are building it from the Ubuntu image. Okay, so and then you run, you get those the basic example. What I'm giving here is this is a Docker file. You are creating engine. So some basic example. So in your final year project, this is a very, you can call it as a service, microservice. Okay, and you need somebody to orchestrate, right? That somebody is nothing but Kubernetes. Okay, so there are many container orchestration. So previously we saw how to build a container. This one I shown you how to build a container. Okay, and what I'm showing you is how to orchestrate the container. Okay, when I say orchestrate, somebody should be monitoring the container, right? Whether it's up, it's gone down, should I start in this server or should I start in the other server in the cluster? Okay, so all those things. Okay, so let me read out this definition of Kubernetes. It's a very interesting one. Kubernetes is commonly referred to as K8s, okay, in an open source system for automated deployment, scaling, and management of containerized application that was originally designed by Google. So Kubernetes actually is designed by Google. Okay, their main goal is to automate deployments. It will help you to deploy your application. It manages the scalability. Once the load is more, Kubernetes will help you to scale dynamically. So based on your load. So Kubernetes scales up and down. So this is called HPA, they say. So in your final year project, if you give a demo on this, see, I'm putting more load when more users are using my application. My system is dynamically scaling. If you can show this to your faculty there as a final year project, that's a very good work. It's an amazing work. So definitely, I would say 100% for this behavior. If you can show me a demo on this, I'll give the entire full mark for you guys. So see, the main feature of Kubernetes are container scheduling. Okay, so somebody has to make sure yeah, one microservices you run here, the other microservice you need to run here. That somebody is nothing but Kubernetes. Okay, so it maintains this container scheduling where the pod should run. Okay, so I'll talk about the pod later. This takes care of horizontal scaling dynamically and self-healing. Like when a service goes down, Kubernetes identifies, oh, there's a service gone down, let me start it. So